All right, let's jump right in. Today, we're looking at a seriously smart solution to two of the biggest headaches in tech and energy right now. First, you've got the insane power demands of AI, and second, you've got this staggering amount of clean energy that our green power grids are literally forced to throw away.
And that really is the central paradox, isn't it? On one hand, this AI revolution is running on servers that need just a ridiculous amount of electricity. We're talking city-sized amounts. But on the other hand, our renewable energy grids, especially in places like Portugal and Spain, are so good at making wind and solar power that they often can't use it all. They're forced to just waste it.
And we're not talking about a small problem here. In 2024 alone, the electricity market in Spain and Portugal had 774 hours where clean energy was so abundant that the price was zero or even negative. Think about that. That's more than a solid month's worth of free, clean power just getting dumped because the grid couldn't take it. So this sets up a fascinating question, right? What if you could take all that wasted power and just feed it directly to the power-hungry AI industry? What if these two massive problems were actually each other's perfect solution?
Okay, let's dive into this, because the core idea here is a total game changer. They call it the Electron-to-Byte paradigm shift. You see, the old way is to try and ship bulky, inefficient electrons over hundreds of kilometers of expensive, congested power lines. The new idea, don't even bother moving the electrons. Convert them into valuable AI computation right where the power is made, and then ship the data, the bytes, over super efficient fiber optic cables.
And this chart, wow, this just shows you exactly why that idea is so powerful. If you look at that bar on the left, selling a megawatt hour of that extra power to the grid gets you maybe 46 euros. But now look at the bar on the right. That shows what you get if you use that exact same megawatt hour to power some GPUs and sell AI computing time. You're generating over 1,100 euros. It's just a staggering jump in value from the exact same resource.
In fact, what you're looking at is a 23 times revenue multiplier. For the same amount of clean energy, you're creating 23 times more economic value just by changing what you do with it at the source.
And here's the other knockout number. It's not just about the revenue you make, it's about the costs you save. It is 67 times cheaper to move that valuable data over fiber optic cables than it is to move the equivalent amount of energy over high-voltage power lines. So you win big on revenue, and you win even bigger on transport costs. So how does this all actually work in the real world? Let's get into the technology behind it and see how this thing is actually built.
So this is the RAIDE Atom. You can basically think of it as a high-tech, self-contained data center in a box. It's designed to plug directly into the existing infrastructure at a hydroelectric dam. It's a genius setup, really, because it's modular, it's co-located with the power source, and it means you don't need any massive new construction projects.
Now, what's really cool are the specs. Each one of these atoms is a 2 megawatt compute node. It uses the dame's own cold river water for cooling, which makes it unbelievably efficient. It gets a power usage effectiveness, or PUE, of 1.03. Now, for anyone who knows data centers, that is insanely good. A typical data center is closer to 1.5. And it's smart. It's got an automated system that can react to electricity prices in less than 50 milliseconds, faster than you can blink.
And that automation follows 4 really simple but brilliant rules. When electricity from the grid is expensive, no problem. The atom just uses the dam's own power. When the price is low, it might buy some cheap power to supplement. When the price hits near zero, it goes full throttle and soaks up all that wasted energy. And my favorite one, when the price goes negative, the grid actually pays the atom to take electricity and compute with it. You literally get paid to compute.
Okay, so this all sounds fantastic in theory, right? But the real question, the one that always matters, is does it actually make money? So let's look at the audited financial results from a real-world test case.
So the primary test case for this whole model was the hydroelectric dam at Miranda do Douro in Portugal. It's one of the biggest reservoirs in the country, and it has a long documented history of having surplus energy. A perfect spot.
And, well, the numbers are pretty stunning. The project shows an internal rate of return of over 33%. The entire investment is paid back in just over 3 years. And get this, even in a combined worst-case scenario, I'm talking severe drought, falling GPU prices, and high interest rates all hitting at once, the model still generates 16 times more value than just selling the power to the grid.
And just to put that payback period into perspective for you, a typical large-scale infrastructure project, you're looking at 10, 15, maybe 20 years to pay for itself. The RAIDE Atom does it in a fraction of that time.
That just completely changes the risk profile for investors.
And in case you're thinking, well, maybe they just got lucky with that one location. Nope. The model was validated at 4 different sites across Portugal and Spain, with different climates, different scales, and the payback period was strong every single time. This proves that the performance is baked into the idea itself. It's not just a fluke of one specific dam.
Okay, so let's zoom out. What does all this mean for the bigger picture? Because this is about way more than just one company's business model. It's about creating a smarter, more symbiotic relationship between our energy grids and our computing infrastructure.
And there's a huge bonus here for the entire grid. By acting as this massive, intelligent, and super fast electricity consumer, the RAIDE Atom network actually helps stabilize the power grid. When there's too much power, it soaks it up. When there's too little, it can power down instantly. This provides a valuable grid balancing service for free, and that reduces costs for every single person paying an electricity bill.
And the vision here is truly ambitious. The blueprint isn't for just 1 or 2 of these atoms. It's for a full hub-and-spoke network of 249 nodes spread across all the dams of Portugal and Spain, creating a massive, distributed, green-powered supercomputer.
And that really brings us to our final thought. This model provides a powerful new way of thinking. It's all about finding stranded, undervalued resources and converting them into high-value digital products right there at the source. So it makes you wonder, if we can turn wasted water power into AI, what other massive waste streams are we currently ignoring?